I am Eric Martinez Loran from Team PV Ward / SolarWave IR, and I'd like to open with a question. What is the real lifetime of solar panels? The short answer should be at least 25 years, but the reality is that it depends on several factors. Our team has been worrying about what makes solar panels last less than 25 years and what is the root cause for the decline in power output. We learned that water plays a key factor in module degradation. This is why, 2 years ago, David Fanning and Rishi Kumar developed PV Ward, an optical detection system that can measure the amount of water in the encapsulant layers of fully assembled solar modules. We received positive feedback from researchers working on durability of solar panels, which led us to believe that this tool could help R&D teams at different levels of the value chain in the solar industry. From solar module manufacturers and power plant operators, we learned of a need for a quality control screening tool to avoid batches of defective devices. Competing technologies have some intercepts with the uses of PV Ward, but no single available technology can render all the functionality. For instance, laboratories working on durability use spectrophotometers and radioactive tracers, which are very accurate but require disassembly of the module. Calcium-based tests can be used directly, but require the introduction of an opaque layer, reducing practical use. Ionic-based moisture sensors can be installed in solar modules, but they can't resolve the concentration of water over the whole module. The only commercial application that comes close to PV Ward is from Moistech, but it does not provide quantitative spatial information. PV Ward is simple and flexible enough to be adapted to different working environments. For instance, in the laboratory we can do motorized measurements to get moisture maps, and in the field we can take point measurements on installed modules. We will reach the segment of scientists and engineers in R&D teams in solar manufacturing companies as our first customer. We think adoption of our technology will spread from this segment. The solar energy industry has a worldwide installed capacity of roughly 590 gigawatts. We will initially rely on direct sales of tools to get revenue. As we consolidate our analytics system, we will move towards a subscription-based model, which will capture more revenue. We estimate that the average price per tool will be $2,500, and we estimate that initially we can sell a tool per power plant which averages 10 megawatts of capacity and adds to a total available market of $150 million. An estimate of major solar plant operators and energy service companies in the US puts our served available market around $12 million. To provide some context on the impact of module degradation, we estimate that reducing degradation losses by half might account for an accumulated value of $34 billion over 25 years. In order to materialize our plan, we need help with financial investment, technical assistance from national labs, industry connections, accelerator programs, and incubator programs. We have connected with some of these resources, and we estimate that this support will help us bring an analytics tool to de-risk solar investments and help provide solar energy for generations to come. Thank you.